Action.
So, Chem, part 2 of the vocab, off we go. First one is 1860s. 2 is Meyer, M-E-Y-E-R, versus Mendeleev, M-E-N-D-E-L-E-E-V. Mendeleev is better because he left gaps to predict future elements that they didn't know at his time. 180 is the atomic number, which, if you'd rather do a synonym answer, the atomic number from last time is the number of protons, correct. So we already memory wiped the whole last vocab test, just took the test, it's gone. 181 is a periodic law. 182 is 18, those are called groups, and they have similar chemical properties. For 185, there's 7, those are called periods, and that tells you the energy level. Extra credit around the area, 182, 184, that zone. The A groups are called the representative groups. The B groups are called transition groups. Some of those columns you've probably noticed over the course of the year. There's like a 1A and a 1B and a 2A and a 2B and things like that. But the A groups are representative. The B groups are called transition groups. 188, if you just say alkali metals, you'd get half a point. You need the column number also, which would either be the normal number 1, or if you like Roman numerals, Roman numeral 1A. I don't care which numbering system you pick. That's A-L-K-A-L-I, metals. Then there's a similar word, alkaline, A-L-K-A-L-I-N-E. Those are earth metals. And that's going to be either normal number 2 or Roman numerals 2A. There's chalcogens, which I'm pretty sure can be pronounced chalcogens, but I'm more sure about chalcogens being the way you say that. It's C-H-A-L-C-O-G-E-N-S. That's normal number 16 or Roman numeral 6A. Then halogens, H-A-L-O-G-E-N-S, is a 17, which is a Roman numeral 7A. Then there's noble gases, N-O-B-L-E, gases, not to be confused with N-O-B-E-L, which is prizes. N-O-B-L-E, noble gases, that's 18 in the normal numbers, and it's Roman numeral 8A. 193-94, there's lanthanide and actinide, L-A-N-T-H-A-N-I-D-E and A-C-T-I-N-I-D-E. If you want a bonus point for lanthanide, you could say synonym name is rare earth elements. So the lanthanide series is rare earth elements if you want to do that. 195 is 4 through 7, because if you look at the table, they're literally just long. The short periods are 2 and 3, because they're short. 197 is attractive forces that hold atoms together. 198 group, there's ionic versus covalent. Ionic transfers electrons, covalent shares electrons. Bonus point here, if you want to explain what's going on with the electrons, basically at its heart, like charges repel and unlike attract. So if you got like a negative charge this and a positive charge that, those are unlike charges. They tend to attract each other. That can help you cause these bonds. But like charges repel, unlike attract. 202 is valence electrons, V-A-L-E-N-C-E. 203 is 8. 204 is hydrogen and helium in any order. 206 is share, then carbon. 208 is gain, then non-metals, then negative. 211 is lose, then metals, then positive. 214 is noble gases, N-O-B-L-E, gases. Again, I'll do repeats at the end so the video people aren't subjected to our repeats right now in 2024. 215 is cation versus anion. C-A-T-I-O-N is the positive, A-N-I-O-N is the negative. 217 is Roman numerals. 218 is an O, 0. 219, it has 2 atoms. And then in no particular order is I for iodine, O for oxygen, N for nitrogen, F for fluorine, Cl for chlorine, Br for bromine, H for hydrogen. Did I say 7? I-O-N, H-F, Cl, and Br? Good. 221 is Lewis structures. 222 is a triple bond. 223 is a double bond. 224 is positive. 225 is, it has 3 elements. 226 has 2 elements. 227 is common, and then systematic chemical. And the systematic chemical, in a twist of chemistry irony, are the more common names. 230 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, numbered off. 1's mono, M-O-N-O. 2 is di, D-I. 3 is tri, T-R-I. 4 is tetra, T-E-T-R-A. 5 is penta, P-E-N-T-A. 6 is hexa, H-E-X-A. 7 is hepta, H-E-P-T-A. 8 is octa, O-C-T-A. 9 is N-O-N-A or E-N-N-E-A, and I'd want to get both of those half a point apiece from you. 10 is deca, D-E-C-A. 240, you only use mono on the second one. 241 is if there's ever 2 vowels in a row, the prefix is going to drop its vowel. 242 is a stock system. 243 is IC, and then OUS in that order. The last one is ATE and ITE. Flipping a page. 247, the 8s have 1 more oxygen. 248 is hypo, and then HYPO, and then the second one is PER. 250 is it's a gas or a liquid or a solid dissolved in water. Gas or liquid or solid dissolved in water. 251, an acid. The formula is HX. The definition is it's a hydrogen compound that yields hydrogen ions in aqueous solution. A hydrogen compound that yields hydrogen ions in an aqueous solution. Base is MOH. So what that is, it's a compound with a metal ion and a hydroxide. The salt is MX. It's an ionic compound with a positive ion and a negative ion. Then you have the most hated quiz of all time, probably through the year. I don't think anybody liked that quiz. Common names, you just have to memorize them. So HCl is called muriatic acid. H2O, you should know, is water. The third one is sugar. Fourth one is dry ice. Fifth one's ammonia, not to be confused with ammonium. Ammonia. Vinegar is almost toward the bottom here. Table salt is the third from the bottom. Natural gas, and then oil of vitriol. The systemic names you don't necessarily have to memorize. You can just kind of make them if you know the rules for naming things. So HCl is a binary acid. So that starts with hydro and has an ic at the end. So that's hydrochloric acid. H2O is hydrogen oxide, just using the names of the elements. The third one is sucrose. You do have to memorize that one. Carbon dioxide, you can just use the prefixes to come up with that. Hydrogen nitride. The H is going to be another acid again. That one's acetic acid. The rules for naming acids, if you know the C2H3O2 from the ions is acetate, and you remember the trade ates for X, because that's the rules for naming acids, it's acetic acid. Sodium chloride, just using the names of the elements. Methane, you'd have to memorize. Sulfuric acid is based on sulfate. We're just turning sulfate's ion into sulfuric acid. And then matching them up, HCl is G. That can be a swimming pool thing, among other things, including cleaning metals. In my swimming pool owning lifetime, I've used muriatic acid to do some stuff with filter parts. I would presume you know water. D is used for drinking. Sugar, I would think C, you know that's a sweetener. CO2, I would think you know that's a greenhouse gas. That's I, among other things. Dry ice used for freezing things as well. Ammonia, A, it's a cleaning product, among other things. Vinegar, H, can be a salad dressing, among other things. NaCl, seasoning, table salt, I think we know that one. F, natural gas heats your home and buildings. The sulfuric acid, B, that's battery acid, also used for cleaning metals. Basically anything that cleans metals can be hazardous to your skin, so you be careful with that stuff. 284, it's an amount, this is a long one, it's an amount that has the same number of atoms or formula units or molecules or ions as there are atoms in 12 grams of carbon-12. And you pretty much need all of that. So it's a number, you need to emphasize that in there somewhere. Somebody at some point counted the atoms in 12 grams of carbon-12 and they got that number. So you need to mention atoms of 12 grams of carbon-12. Somebody got that number figured out. And if you have the same number as that number of atoms or molecules or formula units or ions of anything, that's a mole. So one more time on that, it's an amount, a number, that's the same number of atoms or formula units or molecules or ions as there are atoms in 12 grams of carbon-12. 285, that famous number is Avogadro's number, A-V-O-G-A-D-R-O's number, and that's 6.02 times 10 to the 23rd. To the end. 287 is standard temperature and pressure. 288 is 22.4 liters. 289 is the simplest formula. It is the simplest whole number ratio. The molecular formula has the actual number of atoms, and it's a multiple of the empirical formula. So I'd probably go half point, half point, half point, half point, add it up to 2 points. So for empirical, say it's the simplest whole number ratio. You know, I would just take that. If you just say simplest whole number ratio for empirical, I'm good. Molecular, I'd go 2 halves. The actual number of atoms, and it's a multiple of the empirical. 291 was the chapter right before I came on the scene where I was administering makeup tests and things for people that had been absent. So this is getting pretty recent now here for 291 stuff. It's an interaction among chemicals that brings about change. 292 is a shorthand way to describe reactions using symbols and formulas. 293, there's reactants, which are the substances that interact, and they're on the left in the equation. And I'd like the word equation in there, otherwise it makes it sound like they're in the lab and you keep them on the left or something. But it's reactants, substances that interact, they're on the left in an equation. Products are the substances formed, they're on the right of the equations. Bonus point in this zone, there's some chemical change signals that you could use to judge if a chemical change has occurred. So our list here is gas gets produced, color changed, heat produced or absorbed, or a precipitate forms. So gas produced, color changes, heat's produced or absorbed, or a precipitate is formed. I cheated you out of an extra credit point back a page or two that I just realized. If you could skip back to around 227, if you want an extra credit point around this 227, 230 zone, you can pencil in IUPAC made rules in 1921 so everything doesn't have a random name. Run back of that. IUPAC was an organization. They made rules in 1921 so everything doesn't have a random name, which we saw that on the quiz that I said you hated, where there was like lime and quicklime and oil of vitriol and milk of magnesia. There were all these names, even like water. Why is that called water? So IUPAC got tired of there being all these just weird random names, and they made up rules to have a system to name these names. Back to where we were, which is 297. 297, there's like 2 halves to this answer. It increases the rate of a reaction or speeds up a reaction. second idea is it gets recovered unchanged at the end. Speeds up a reaction, recovered unchanged at the end. 298, there's the arrow that separates reactants from products. There's also a plus that separates reactants from reactants, products from products. 302 is a catalyst. 303 is heat. 304 is combination. There's decomposition. There's single replacement. There's double replacement. And there's neutralization. 309 is oxygen. 310 is burning. 311 is a solid that appears in a solution during a reaction. So you have all these things that are liquids. You mix these liquids together and it's like a magic trick. Boom, there's a solid there that just appears like a rabbit out of a hat. So a solid that appears in a solution during a reaction. 312 is hydrogen and then ITE. The OUS acids had ITEs. So if you had like sulfite, it would turn into sulfurous acid. If you had nitrite, it would be nitrous acid. Anything that's ite, when you put hydrogen with it, it becomes an OUS kind of name of an acid. The IC acids are the 8 ions. So we saw that a minute ago where sulfate became sulfuric and acetate became acetic. 315 is 2 or more elements, and that's memorizing. That's all the stuff like what I just said, sulfate, sulfate, nitrite, nitrate, carbonate, things like that. You had to memorize those once at a time, upon a time, and I think that's the next part of the test. Monatomic ions are 1 element. If you have a 1 element ion, that ends in "ide" always. And the charge there is by using Roman numeral on periodic table. Roman numeral from periodic table. And that's a wrap on that.